Kubernetes Blockchain Powered. This is a very nice topic to consider because when your favorite scheduler meets IBM Hyperledger Fabric, weird things happen. And that weird word is not that weird. So let's start together to consider this specific topic and whatever is related to technologies that are rounding this concept. I am Fabrizio Sgura, the chief engineer at Veritas Automata. We do a lot of things, but one of the things we do is related to Hyperledger Fabric and the technologies that are involved in trusting automation. So you can scan my QR codes, you can keep having conversations and a relationship with me. We can talk about this and more. We are using Kubernetes in our current reality. So our topic today will be yes, Hyperledger Fabric, yes, Kubernetes, and how we do that without a specific operator. So without orchestrating that with extending the API of Kubernetes, but having an effective automation that is self-made for the moment, and it's intended to do the deployment on top of the infrastructure network, and at the same time, the ability to provide the runtime of chain code to be inside our deployments and many other things that we will see together how we do it. It will be a very brief concept on how everything is deployed, but you will have the idea. And if you are not familiar with these kind of things, you will also have the will to go to investigate and start to discover how Hyperledger Fabric is working in Kubernetes and how we adapted it. In the agenda, we see that we have obviously the introduction. We cannot have a different thing when starting. Then we will consider why we are using Linux as starting point, specifically the Ubuntu distribution. Kubernetes as the distributed system scheduler. There are no big opportunities there. There are a lot of tools that worked in the past for scheduling, for having orchestration, but Kubernetes is the de facto standard for the current times, so we use it very proficiently. Hyperledger Fabric is the framework from IBM that we are using for running this serialized type of blockchain. Kubernetes network and Hyperledger Fabric network are two concepts that are not really the same, but we had to adapt this Hyperledger Fabric to work on top of Kubernetes and vice versa. There are also storage considerations that probably we will not cover in this specific podcast, but you can follow up with questions later on storage, so you already have a hint, a spoiler on how to ask for questions. A specific one is related to where we store the information of the certificates, the TLS, and many other things. Then a sort of advice: stop using Docker Compose when you are using your experiments, especially if the target of your deployments is related to Kubernetes. You should start from Kubernetes itself. Then we will cover intentions and actions. What are these two concepts that are very related to the transactions inside the blockchain? So an operation that in a state machine will consist of a final state. Then chain code and transactions, conclusion, questions, answers, and whatever more related to the follow-up if we stay in touch. So the exciting fusion of Kubernetes and Hyperledger Fabric can really bring us the opportunity to transform our applications in a trusted framework. And if you are ready to explore how we do that, how you can implement the deployment strategies, if you are already familiar with Fabric, you probably know about the bash scripts to create a Docker Compose-like deployment. Well, that is not the only thing that you have to do, because Fabric is not just a network deployment, but it's something that will give you the ability to develop trust in automation on top of Kubernetes. And with trust in automation, you will be able to control a powerful state machine and all the logic that is behind of that. If we think about the subjects that you should investigate to have more context about Hyperledger Fabric, but not just that, the Linux Foundation is constantly maintaining the certification program for Hyperledger Fabric and Foundation. You have now specific certification that is Hyperledger Fabric Practitioner, a level that will give you the ability of understanding all the things that we are doing here. Then the CNCF, the Cloud Native Community Foundation, this is a key player effectively in sustaining and integrating all the open source technologies and Kubernetes, and it's the must go for having the integration available for whatever components you are trying to bring to your internal system or Kubernetes distribution. The Hyperledger Foundation, they have a lot of documentation, videos, and I brought here Imagine a Digital Fornox because it's really where you can find everything about Hyperledger, current status, old status, deprecations, and future things to come. Kubernetes community, we are part of it. So it's very important that when you have a problem, you refer not just to Reddit or other communities that are blogs on top of the deployments that we have on the internet, but you go for the people that could be on Slack and other parts, social networks for integrating with the Kubernetes community. Why we chose Ubuntu? It's because we work at the edge with edge devices, and we have an over-the-air integration that is done based on the Yocto distribution that is very near to Debian as a concept. So Ubuntu is a natural consequence of that specific landscape. And we decided to go for that because we are using most AMD 64 architecture for our edge devices, generally Intel NUCs or similar computing machines. So we are not just talking about Kubernetes on the clouds today. We are also mentioning that we are working at the edge with specific bare metal components, generally single nodes components. And from those peers of the main cluster on the cloud, we will produce our transaction flow that will be the initial approach for having this deployment of Kubernetes organically combined in this special stack. The kernel of Linux is not really important for Hyperledger Fabric, but it's important because of the namespacing, so the ability of having isolation in Kubernetes from where you can benefit with specific deployments and isolation for your customer chain code applications running on top of Hyperledger Fabric. And Ubuntu is giving us that ability, so it's a very flexible operating system. Now, again, a little bit of context here. Docker Compose, you don't have to trash it. It's very valuable. Docker is the basis of where we are today. So it has to be respected. We still respect it. But for our context, you should move to a concept of moving everything inside Kubernetes. So whatever you do in Docker Compose, learn about deployments, how to do stateful sets in Kubernetes, how to use the storage, and whatever is related to your current ecosystem in Docker Compose, also being a test environment, please do an exercise and transform it in something that will work with Kubernetes. It will be a benefit for you, and it will work better because you will have more control on Hyperledger Fabric network deployment and translating that kind of workloads that you have on Docker Compose. You will also learn a lot about the system that you are using. So I call it here the magic ones, blockchain networks and Kubernetes. You will find very poor documentation on the internet because generally having blockchain networks on Kubernetes is still a challenge. There is some operator there, one deployed and developed by the community, maintained on GitHub, so it's publicly available. Another one that is the Kung Fu operator that you can use that for deploying on top of Kubernetes your Hyperledger Fabric stack, but really nothing is really working as you expect. It's first of all, a long learning curve to get all the concepts together. And with that operator, the Kubernetes role being the effective conductor of the orchestra is still obfuscated by the responsibility that an operator for um, Hyperledger Fabric should have. So we decided and opted to do exactly what I was mentioning earlier: deployments, eventually Helm charts, but not working for the operator at the moment. We will do that in a future opportunity when having better integration with Hyperledger Fabric and the newer versions. And the contribution Fabric is effectively the guardian of the data, but also the guardian of the transactional engine. So whatever is happening out there that will require storage, safe storage, immutable storage, Hyperledger Fabric is the guy that is giving us the ability of achieving that. Here, a real example, this is a Lens screenshot. So it's Kubernetes pods. For this case, you see here that they are specifically pods of a namespace that is running on the cloud sides of our customer network for Hyperledger Fabric. We have some components that are related to the Hyperledger Fabric client. Then there is the intermediate certificate adapter, the root certification for the Fabric certificates, so the TLS. We have the peer. We have an NFS provisioner for block storage. As I said, storage is very complicated. We will not cover here in deep, but it's a topic that should be an interest for everyone that is approaching the same problem. And some jobs to do the networks, so it's just a job inside Kubernetes doing a one-shot activity. The classic ECR credential for grabbing the image from ECR for each component. So all the images are here. Certificate rotator, it's safe to have one. And this is the stack that we are running on the cloud. No ordering service on the cloud, because in our case, the decisional power is taken just locally. But if you know a bit of Hyperledger Fabric, you will understand that putting an order on the cloud or 3 on the cloud and 1 locally will play with the consensus. We can do that depending on the needs and the network topology that we are going to use. All the things related to mapping orders, where they are. So we see that here the namespace is having a -L. It's a convention that we are using for saying local on top of the edge device. The domain that we are associating to that is a core DNS mapping. We are using the services of Kubernetes, like you see here, and SVC is typical of that specific approach. And using the Kubernetes network implemented on top of the basic services, private network behind a VPN, we are able to produce something that via a config map, there is no sensitive data here, via config map, we are providing the mapping to the components to see each other on top of this Hyperledger Fabric network. There are also other configuration files that are related to how we want to provision the components, and a public key for the user, or private key in this case is PKI, so both, for the user to interact with the initial access. Then here we have edge pods. While we were seeing earlier the cloud pods, we have the edge pods. As you see here, we have the orderer Again, we are using just consensus on the local for this application, so it's the simpler case, and the order is one, and it's running on top of the edge device. So everything that is based on where a transaction is started and committed is here at the edge. For the edge, the config map is similar, but we have no references to the orders on the cloud, and everything at the edge is working locally as a sort of decisional power node that is just peering to the cloud elements, the information, and distributing the transactions that are committed via peer, and also endorsing from the cloud if we need to endorse some kind of transaction. On the distributed scheduler side, this is a word that I chose to describe what is the whole network of Kubernetes that is giving us the ability of distributing this information. So using Kubernetes to distribute the system, we can automate deployment not just on the local side, but also on the cloud side, and both with tools like, in example here, we are using Rancher Fleet for deployment both sides of the network. And with the distribution like this, we can stop thinking about disaster recovery because everything is peered and available in other sites. So it's up to us to deploy and develop a specific network that will be redundant, not because we have backups, restores, or whatever disaster recovery the traditional way, but because we are available on many sites at the same time. Kubernetes ensures that your application runs smoothly and efficiently. So it's important that you consider that it's not mandatory to scale up and down. Everything will be driven by Kubernetes. And this I call the distributing by consensus, because when Fabric is working for you on Kubernetes and using the Kubernetes network, you will be able to follow this process and to benefit of the distribution by consensus of the logic of your applications. Kubernetes has the Hyperledger Fabric scheduler. So we saw everything now on how we do that. And Kubernetes, for this case, is a framework that is a scheduling system with whatever you should know about it. If you don't know Kubernetes, please go and learn it out because it's very important for many other appliances. But here we noted that for our needs, for blockchain applications, for considering the delivery of chains or chains of delivery for chain codes, applications that are running on top of Hyperledger Fabric, it's very important, key, and it enables scalability and flexibility that you will really realize it's a fantastic option for your expansion of the application, for trusting automation, for whatever is related to ensure that the data is committed and available, immutable inside the Hyperledger Fabric ledger. The networking for supporting this trust in Kubernetes, I mentioned some technical components like Calico to Cilium. The CNIs generally are a standard in Kubernetes for adopting a specific network stack, network deployment. You will need something like a VPN or an integration to close this system out from the world because you want to have it obviously abstracted from what is the security and the public zones that could be from the cloud to the local. Including the right CNI is a key for managing all of these things and thinking about the future. Cilium, based on eBPF, but also Calico, it's an option considering new technologies that will grant us the ability of having advanced networking. And it's one of the reasons for why we are still not developing and using a real operator for our case, because we want to wait for more opportunities for these CNIs to have them working with technologies like eBPF and better service mesh and strategies that will consistently reduce the um, complexity of the system that is based on TLS integrations between components. So think about replacing the TLS with a service mesh or something like Istio, in example. You will spend some time to configure Istio. You will have a big benefit because all the things that you have to do on certificates and similar will be available from Istio. But on Hyperledger Fabric, this will not work because Hyperledger Fabric has its own CA, so it needs its own certificate management. It's not intended to work without encryption. All of these small dependencies are letting us think that leveraging eBPF or other tools that are related to a better network will be key in the next times for having an operator. Here is a brief view of the Fabric components, the implementation of a network with two organizations for our case. So in this case, we will have consensus from two sides, and you have the orderer, that component that I was mentioning. Look, it's here, but only at the edge, where you have an organization that is taking a decision with another, depending on the policy. They can be based on an and rule that is inclusive for both, or an or rule where you have one or the other that is taking the decision. This is quite typical initial Fabric network components deployment, and is what really on Kubernetes, for our case solution, is already working quite fine. In Hyperledger Fabric operators, I already introduced the names and cases. Are they really helpful? Well, for your personal research and integration, why not trying them? For the learning curve, you will spend a couple of weeks to understand how the command line works, how the orchestration in Kubernetes is done, how the chain code is deployed on top of pods that are running controlled by the peers inside the rest of the deployment. You will learn a lot of things, but not in deep because you are not doing the things manually. So initially, like for the service of the Docker compose.yaml file that you could use for your initial deployment, you should really focus on the manual deployment on top of Kubernetes, getting crazy with help charts or writing us, and we will give you hints to go ahead following the same idea that we are following right now. So the two operators are a valid option, but they are really complicated, and probably it will be something that you will have to manage in a lot of time. They are also not effectively approved by the CNCF community. They are still before of the incubator phase, so there is still a lot to do. They are neither sandbox. It's effectively something that you have to think about if you want to adopt this technology, and it's better that you know how it works in the organized way. The platforms, like the one that we are building for you, is generally something that will help you a lot because you will just run Kubernetes as a service, Hyperledger Fabric as a service on top of Kubernetes. We will use for you the components and the distributions of Kubernetes that are security based, like RKE2. We are using that on the cloud for specific deployments. We are also using K3s at the edge. They are binary distributions. You can research how Rancher is maintaining that specific ecosystem, but they have a lot of power compared to other Kubernetes distributions because they are not cloud-based, they are not vendor locking, they are binary distributions focused on security. They are easy to use, generally bundled with a lot of instruments like the SCD snapshot without bothering about that too much. It's just a subcommand and many other things that will help you develop a better software instead of thinking too much to the infrastructure. And we do that for you. The platform that we have housed in Veritas Automata, we have that running many solutions, actions, transactions, Hyperledger Fabric, and it's based on Rancher K3s. The platform context to create workflow is related to that part related to action, transactions, what I was mentioning at the beginning. A transaction is something that is very committed to be immutable. So you are on a final state of a finite state machine that has to be committed as the truth about something that happens for your application. Like an example, you are creating orders for whatever reality for a dress shop, and the customer is picking up the bag with whatever he or she bought in the shop and they are leaving. That is the conclusion of your workflow, and that is a committed transaction where you will say both. And that both is stored immutable at the right time with the right conditions, whatever is related to the environment and ecosystem that produced that specific result in the Hyperledger Fabric network. Actions are all the intentions and ideas and conditions that are out there for producing these transactions. So for actions, generally we don't use Hyperledger Fabric, but queues. In our case, we will see that in our platform, the queue is managed via a NATS service. It's very similar to Kafka or ActiveMQ, but it's distributed. Again, we follow that paradigm that we want to distribute everything to be highly available and redundant. On running chain codes, I mentioned a couple of options. One, the native one is running chain code inside the containers of Docker. So using the Docker daemon exactly the same way that you will do with Docker Compose. Another one is to run the pod inside the Kubernetes cluster, and that requires more interoperability by your side, because actually the Kubernetes pods are not intended to be native resources for Hyperledger Fabric. We do that. Also, the operators are working on that specific standard, but it's not really available. So in the documentation, you will find how to instantiate and run chain codes, the applications for producing those transactions inside of Docker containers. Here we have the challenges. Generally, when you have a so complex architecture and components, you will have to face the typical network challenge, the network complexity in managing blockchain nodes, the peers, the orderers, how they talk each other. Kubernetes is fantastic because it's already giving you services and an opportunity for automatic service discovery. And that is really the key for using Kubernetes for this, and not just hard coding, because as soon as you scale up your components, that will create a lot of problems if you don't have service discovery. Performance and security across the integrated system is again from Kubernetes. We can scale it up, scale it down. We have a lot of tools like Pod Autoscaler for ensuring resources, limits, and so on. A lot of tools that will help you having a look of how everything is deployed and available. The persistence and state management in a distributed environment is very hard to achieve if you don't have an orchestrator. So suggested solutions are derived from that concept. Not written here, but obviously the ability of creating deployments and something that is declarative, utilizing advanced network plugins and tools like the CNIs I was mentioning, implementing robust security protocols and regular performance audits. In Kubernetes, you can do that. And finally, leveraging Kubernetes stateful sets for effective data management and storage for sure, persistent of storage. The bright future, we are just starting to have Kubernetes and Hyperledger Fabric working together. Blockchain applications are still something that are far from our current realities. Generally, we do microservices, the old style with messaging, domain-driven design, and similar. Chain code applications, blockchain applications are based on when you commit the transaction, the block that is describing the ecosystem, environment, and context of that transaction, and that's immutability, because it's impossible to change a block without affecting all the rest of the blockchain. And so you can damage data, but you cannot effectively wipe it or replace it. Enhanced automation in blockchain network management, increased focus on security and scalability, integration of AI, very trendy today, and machine learning algorithms for smarter blockchain networks. These are all possible emerging trends, and maybe one of you would be the actor for this. Potential developments: more robust and user-friendly orchestration tools, again, the operator on top of Kubernetes, exploration of cross-chain functionalities, emphasis on sustainability and energy efficiency in blockchain operators. Now, whatever you can think I haven't covered enough, or it was just brief for you and you want to learn more, and you are interested in experimenting with Hyperledger Fabric Kubernetes, or knowing more about our platform, knowing a little more on how we do that storage parts, whatever question not related to the current weather, please come to us and ask. We are really happy to share all the research that we did on top of Kubernetes for Hyperledger Fabric, for orchestrating the integrations, not just related to the blockchain, but to that actions context we were talking about. So messaging and whatever is related to have a trusting automation working system that is based on your favorite scheduler, that is Kubernetes for sure. Want to learn more? Read also my thought leadership. We have a site that you can reach via these QR codes, and you will have a lot of considerations, not just by my side, but by all our expertise team that is considering things like Kubernetes, digital twins, machine learning, pharma, a lot of things that you could be interested on. So thank you, everyone. This is, again, my LinkedIn code for the connection, for following up. It has been a pleasure, and thank you for your attention. See you soon on LinkedIn and social networks. Goodbye.